We're going to finish up our discussion of functions by talking about the scope of variables and also giving you some hints for how to write your functions. So we're going to start with variable scopes, and then the writing of the functions is going to involve some tips about how to use incremental programming to write functions, and also some style considerations. So let's start with talking about scope of variables. And what scope means is where the variables live and who can see them. So variables declared in a function, they're local to that function, and they cannot be used nor can they be seen from outside the function. It's as if there is a wall around that function and outsiders cannot look into it. So we say that local variables declared in a function have the function as their scope, and we say that they're reborn each time the function starts and they die each time the function returns. So each time the function starts, their values are copied into the parameters. If any variables are declared inside the function, then they are reinitialized, or they start life again as undefined variables if there's no initialization statement. And when the function returns, these variables go away. At no time can they be viewed from the outside world. Now, the one exception to that is when you define a parameter or declare a parameter as a call by reference parameter. Remember, a call by reference is an output parameter. And when you do that, you in effect create a window into your function, a limited window. Just like a window doesn't often allow you to see the whole room, it might allow you to see a chair or a desk. That's the same thing here. A call by reference parameter creates a small window that allows the outside world or the calling function to peer in and see that one variable's value and have and change in response to it. But otherwise, that's kind of the one exception. Otherwise, any variable declared in a function cannot be seen outside of that function. Since main is a function, it follows the same rules. Anything declared in main is visible only within the walls of main. Any function that is not main cannot peer into main and see the contents of main or the contents of variables in main. So as an example, here's a piece of code that declares the function area to be a double or returns a double, taking two doubles as arguments. In main, we declare length and width. Then we query the user for the length and width of a square, really a rectangle, and read the values, print them out, and then we say the area of the rectangle is, and we call the area function. In the area function, we declare length and width, and we print them out, and then we return L times W. So actually I need to also have L and W here. So length up here, let's say the user enters 10 for length and 20 for width. Many of you are going to mistakenly now assume, well, first of all, you're going to mistakenly assume that magically, length and width down here are also 10 and 20. They're not. They cannot peer into main. They are completely separate. They're declared internally to area. They have undefined values. They're question marks. So don't get suckered into thinking that local variables that have a same name in main that somehow they can see into main. They can't. Main has opaque walls around it, and length and width in main are invisible outside main. We did, however, share some information with area. We passed length and width as arguments, and they got matched up with L and W. So L got set to 10, and W got set to 20. So here, when I output length and width, the output truly is unknown. See, length and width have question marks, so we don't know what the output is. We do, however, when we return L times W, L and W are defined, so we return the value 200. Just like, now going back here, length and width are called local variables because they are declared inside of area. The parameters L and W are also considered local variables that are visible only within the function. And the call by value mechanism, remember what it does is it copies the values of the arguments into the parameters. And the parameters are input only in that case. If I declare the parameters as reference parameters, remember how we do it? We use a ampersand. Now these are called by reference parameters or output parameters. And now, in addition to, in effect, the values being copied into L and W, they also would be able to modify the values of length and width. These values of length and width in main, because L and W are associated with those values. Now, you've seen some other ways to declare variables. One of them is to declare constants. And we have typically declared constants outside main. In fact, we typically put them before our function prototypes. These constants are called global constants because they're independent of any function. And because they're global, they're visible inside of any function. So here, when I ask for the value of pi, it's available to area. I could also have output the value of pi here. If I said pi equals pi, it also would have been visible inside of main. So global constants, those constants declared outside any function, are visible to any function. You'll also see the book talk about something called global variables, and if you look at the internet, you'll see global variables. They are variables that are declared outside any function, and unlike a constant, they can be modified. So double area, if I declare it outside of a function, it can be seen and modified anywhere. So local variables are declared inside a function. Global variables are declared outside of all functions. Local variables can be seen only within that function. Global variables can be seen everywhere. But should you declare a local variable, like I did here, that has the same name as a global variable, the local variable masks or hides the global variable. So when I look at the value of area here, C++ grabs the local value of area, which happens to be undefined. It does not print 20, it prints some arbitrary garbage. So local variables mask global variables. And here's a pictorial way to envision local and global variables. So global variables are declared outside of any function, whereas here in main we have area was declared as a double, and in compute area we had width and height as parameters and area as a local variable. So parameters and local variables are all contained within compute area. they are not visible outside of it. So main's area is invisible to this area. Even if I said area equals 30 here, the value of area is undefined. It's not 30 because it can't see into main. It's not 20. You may say, well, why isn't it 20? Because area is a global variable. It's because I declared this area locally. It has its own existence, and it is undefined. So it's important to realize that variables defined inside a function have very limited scope. Now, I'm going to tell you how a function references a global variable. Should you use a global variable in a lab, you will lose points. They are awful. They are part of the language. You'll see them in the book. I need to talk about them. You should never use them in a program in CS102. And if you do, you will lose points. But here's a global variable area. Since I did not define a local variable called area in main, when I do this assignment of width times height to area, the global area variable gets modified, and here when I print area, the global variable gets printed. Again, I know I'm beating a dead horse. Some of you won't figure out or will be confused about how to pass parameters, so you'll want to make variables like area global. Don't do it. You'll lose a lot of points. You need to learn how to pass parameters between functions, and that's the only way that you should be sharing information between functions is with parameters. Okay. So moving on, the last topic we want to talk about with functions and with programs in general is incremental programming. When you design a program, I suggest you first start by trying to write short pseudocode description of the program. Pseudocode is a mixture of C++ and English that allows you to ignore C++ syntax, but it allows you in effect to rough out a program, just like you might rough out a design if you were doing a woodworking project, or if you're going to do some sewing, you might rough out a sketch. It's a good idea to kind of rough out a program. Sometimes you'll draw some diagrams or pictures and play with them. And I'm not asking you to write a detailed outline, just a very general description of what you hope to do. Then you should, instead of trying to write the entire program at once, you should write it a little bit at a time, test each little piece, and then once that piece is working, you can add a little bit more to it, test the little bit more that you added, and keep doing that till you complete the program. The advantage of incremental development is that you're usually pretty confident that if there's a bug, it's going to be in the part of the code that you just added. So let's say we have two different programmers, Brad and, say, Smiley, my dog. Smiley doesn't know any better and writes her 200-line program all at once, and there's a bug. Well, Smiley needs to look at 200 lines and try to figure out what went wrong. Me, I write, say, 20 lines, test it, something's wrong, and now I only have to look at 20 lines, or 1/10 the number of lines that Smiley looked at. Who do you think is going to find the bug faster? Probably me, all other things being equal. And if those 20 lines work, and I now write an additional 20 lines, and something goes wrong, I probably only have to look in the most recent 20 lines I wrote in order to find my bug. Again, I'm likely to find it much more quickly than Smiley, who's looking at 200 lines. Okay, so write a little piece. So for example, you might write the input part and then use cout to make sure that you're getting the correct values, and then add a small feature and test it, another small feature and test it. So let's use an example. Let's say I want to write the miles per gallon program that you saw earlier in the semester, but I want to put the calculation itself in a function called miles per gallon, and then I want to have my program prompt the user for some input values, and pass them to my function. Then I want to write out the results of the function. And finally, I want to allow the user to repeat the calculation as many times as they want. So I want to develop the program incrementally. The best way to do it is to start by writing the functions first and testing them. So here's my miles per gallon function, and I don't need to change the parameters, so I declare them as call by value. And I do need to cast miles driven to a double using static cast because I want to do floating point division. So I return the value, and before I go much further, I should just test it, make sure it works. So I'll write a small main program to test it, and I don't even prompt the user for some input. I just initially make some function calls with hard-coded values and test them with some sample values. So first I tried it where I knew I was going to get an integer result. And then to make sure that it worked properly, if it was a floating point result, I passed in two numbers that would cause a floating point result. Okay, once I'm sure miles per gallon works, now I can add some code to query the user for inputs. So I add some variables to hold my inputs, then I query the user, then I read the values, and finally, I pass those values via the variables miles driven and gallons consumed to miles per gallon and print it out. Okay? I still haven't finished my program. Remember, there's one step remaining, which is to allow the programmer or the user to repeat the calculation as many times as they want. So the final thing I do after I make sure this code works is I add a while statement that keeps performing the calculation until the user enters a negative number. So I made sure that I still had my priming read, because if the user doesn't want to do the calculation for some reason, I need to never enter the loop. But then once in the loop, I print out the miles per gallon, query the user for another one, read in the miles driven and gallons consumed, and go back to the top of the loop. And that would finish my program. The last thing we just want to talk about is some style with considerations with functions. Remember that we want you to declare your function prototypes before main, put your function definitions after main. Also, we want you to use meaningful variable names for your parameters and variables. Preferably, I would actually not want you to have your parameter names have the same names as your argument names, because it will just confuse you and make you think that they have to be the same when they don't. And remember that when you use call by reference, you have to put an ampersand after the data type but before the variable name. With commenting, we typically like you to put a short comment before your function prototypes to tell us what the function is doing. If you use good parameter names in your function prototype, then you won't have to comment those. It should be self-explanatory. Your function definitions should have somewhat longer comments because they generally should say what the function does, any unusual actions that aren't just obvious if you look at the function, and perhaps anything unusual about the parameters. So as an example, here's what you might put before a function prototype, just a short comment, computes miles per gallon. Here's something a little longer before the actual function definition, and I'm just saying that I'm casting miles driven to a double so that floating point division gets performed. Again, you can do it either by multiplying it by 1.0 as I did here, and another way, remember, is with a static cast. I could have said static cast double miles driven. Either way would work, but that was something unusual. It warranted a mention in the comments. And that's it. You now have the main components that you'll need for basically however many years you spend in programming. You've seen how to declare and use variables. You've seen assignment statements, which assign variables values. You've seen input-output statements that allow you to get input from a user and to output program results to a user. You've seen if-then-else statements that allow you to take one of two branches or actions depending on some choice you make. You've seen loops, which allow you to repeat a computation as many times as you want. And now you've seen functions, which allow you to abstract out a piece of code and reuse it multiple times in your program, yet only declare and define it in one place. The rest of the course is basically just going to be taking these concepts and expanding on them.